Okay. Third problem, you're given a point, just a point. So let's say negative 2's here, 2's here, negative 100 here, 100 here. Okay? And you're given this point. And actually, we need to go more than negative 2. Let's go negative 10 to 10. Because you're going to horizontally shift this by a number that matches the letters in your name or whatever. Okay? So you could easily have to shift 10 units. Okay, anyhow, this point lies in the graph. So let's just say that this point is see how it says. Okay, both of the shifts will be positive. Okay, so I can label it here. Let's say this is 3, 12. Okay. Now, what are we going to do? It says it's vertically stretched by factor D. Okay, where D is something that's calculated by the scheme, and y'all seem to be doing okay with that. Okay. Do remember that your A, B, and C can't all be the same. We talked about that last time. Okay? Got to use that algorithm I gave you, 4-step algorithm, or they're really 4 steps. You really need all 4 steps, but you add ones until all the numbers are different. Okay? And hopefully everybody understands that. So be sure you do that. Okay, so this point's on the graph. It's vertically stretched by factor D. So let's just say that D is, let's see, what's E? E is the difference there. Okay, so it's going to be a fairly small number. So let's say we've got it vertically stretched by factor 3. Okay, we're going to do that in yellow. That means the Y value becomes 3 times as great. Okay, multiply the Y values by 3. Well, what's the Y value? And I want to see the arrows. Here's your Y value. That arrow has a length that's equal to the Y value. Y value happens to be 12, but I want to see the arrows. I don't want to see you say, well, 3 times 12 is 36. I want to see the arrows, okay? So here's your Y value. Represented by this arrow. So 3 times the Y value is this, right? And I can say that, okay, this arrow is 3 times the Y value. To get the Y value, you got to go from the x-axis to the point. Vertically. That's where your Y value is. You should know that, and I think you do. Okay? And what I'm seeing when I ask you to do vertical stretches, I don't see this. I don't see this arrow, so you got arrows on there in most cases. Okay, I'm not sure I've seen one that's correct. I've seen a couple that look like they might kind of be correct. It's still not completely clear. Now remember, you probably want to look back at the video where I did this for the whole function. Of course, I'm going to do one here, because that comes up next, I think. Okay? This is how you do a vertical stretch. It doesn't look like a vertical shift, because if I have another point out here, this arrow is going to be longer, so 3 of them, all those arrows are going to be longer. Okay, you don't use arrows of the same length to do a vertical stretch for that reason. You want to really understand that. Okay. Then we do a horizontal shift of C units, whatever C is. Okay, so let's say we do a horizontal shift of 4. Okay? What's that mean? It means we move 4 units in the horizontal direction. So how big is 4? Well, there's 10, so there's 5. 4 is not much less than 5, so it's going to be like this. There's your horizontal shift of 4. And then we do a vertical shift of, let's say, 12. That 12 is a number I had there. Ouch. Let me use a different number. Trigger finger. It didn't pop. It did something weird. I gotta get that thing fixed. Easy fix. Okay, so vertical shift, let's say 15. Okay, how big's 15? Well, there's 100. So there's 50. There's 25, so 15 is about like this. It's a vertical shift of 15. And here's our point. That's how you do it with one point. If you have a graph, you do it with every point of the graph. Of course, there are infinitely many of them, and you don't have time. Okay? Uncountably infinite, you really don't have time. Okay? So you do a few representative points. Okay? And that's all I've asked you to do. And then to, of course, tell me what the function is. So, fourth problem, we're going to do this with the x squared function. Okay? We've already done it. So I'm going to do a different function. Okay? So let's say we have the one over x function. This is number 4. Because you don't know what function I'm going to ask you to do this with. I'm going to ask you to do it. Okay? You're guaranteed you're going to have to do this. Which ought to be motivation to make sure you know how. And I know it is. Okay, so the 1 over x function well, I'm going to kind of compress the scale. Actually, it's positive 2. And we'll put negative 4 here and 4 here. So I have room to stretch it and shift it. Okay? So you know that the graph is going to have a point like here and here and here. So it's going to at least look like this, and it's going to have an asymptote and all that stuff. You can put that in. And then you got a point like here and here and here, so you've got this. And you can extend it. I'll go ahead and kind of extend it in light. Not a great representation of the graph, but you understand what you're seeing because you know this function. Okay? Now what you do is you take 5 representative points. I think I said 5, I'm not even going to look. Okay? So you take your representative points. I'm going to take one here. I'm going to take one here. I'm going to take one here. And similarly over here, not necessarily symmetric with respect to these, but okay. And I'm using 6. So I'm using 3 on each side, right? So when I do this, I might say 5 or 6, because the 1 over x and the 1 over x squared, you probably need at least 3 points on each side, okay? If it's an x, 2 to the x, that one's really straightforward. You can get by with 5 points, okay? Use your judgment. Okay, so let's just do the same. Well, I can't do the same shifts I did here. Let's say now we have a vertical stretch by factor 3. Okay? What do? Well, we do the same thing we did with this point with each of these points. So this point, I gotta do 3 of these. It gets me to here. This point has a much longer vector. So it's going to be way up here. Okay? Didn't even leave myself room to do it. It's encroaching on this graph. But you see what's going to happen. It's going to be real close to the y-axis and much higher. Okay? And this point is real close to the x-axis. So 3 of those vectors, 3 of those arrows, don't amount to that much. Okay? So now I'm going to draw the graph. Okay? It kind of comes down here like so. And here. And then same thing's going to happen here. You're going to have 3 of these. You're going to have 3 of these. And you're going to have 3 of these, but they're going to go way low. You're not going to be able to do it if that's the bottom of your paper. Okay? But you understand it goes way down. Okay? And maybe then you modify, well, let's not pick a point where it's quite so high, right? Pick a point that you can keep on your paper. But you then graph through these points. And you get something like this. Okay? So that's after your vertical stretch. Again, you all are doing pretty well with horizontal shifts and stretches, but not quite as well. Horizontal and vertical shifts, I mean. But you're not doing very well with the stretches, so make sure you get that straight. Okay? Then the shifts are pretty easy. So then we do a horizontal shift. Of, let's say 4 units. So 4 would be about this long. There's 2. Here would be 4. So I'm not going to try to draw this. I'm just going to mess up this graph. You understand where it's going to go. This point here then moves over 4 units. This point moves over 4 units. This point moves over 4 units. This point moves over 4 units. And this point down here, which you can't get to, you see what's going to happen. Okay? So it's like you're taking this whole yellow graph and moving it 4 units to the right. And it's going to look exactly like that's what you did. It's going to come down like so. And over here, it's going to come down like so, with the asymptote at x equals 4. Now I didn't make my arrow quite long enough. If that's 2, that's not 4, that's more like 3.5, right? I'm not going to get too picky about it as long as you show me what you need to show me. Try to do it as accurately as you can, because it forces you to think more clearly. And then we're good. Orange. And then we do a vertical shift. Of something we can keep on the graph of 6. Okay? Now there's 4 units. 6 units would be about half again as long, right? The vertical shift of 6 would be about like this. So when you show me a vertical shift, it better be something between 5 and 7, okay? Something that's reasonably interpretable as a 6. If it isn't, well, as long as you're doing the arrows the right way, it won't be a huge penalty, but it'll be a penalty, right? Okay, so we go up 6 units. And of course, every arrow that's 6 has to have the same length. And over here, we go up 6 units, so this point goes up 6 units, which will put it about here, and things are getting messy. And this point goes up 6 units. And a point down here will go up 6 units, good idea to show it. So now, your graph looks like this. Okay? It's got a vertical asymptote at x equals 4. And it has this shape. It's more elongated, kind of stretched out compared to this graph. You see this graph is steeper than the white graph we started with. Okay? At every corresponding point. And then, I'm not sure I asked you to do it, but I could. Okay? Vertical stretch by factor of 3 gives you three times 1 over x squared, which is just 3 over x squared. You shift horizontally 4 units to the right. Well, that gives you f of x minus h, which is f of x minus 3, meaning in the f of x, of course, implicitly, f of x is 1 over x, then f of x minus 3 is 1 over x minus 3, right? Okay? And I'm a little careless because if this is f of x, we don't know what this is, and this is something else, so I've got to rewrite that. Y is 3f of x. When you do vertical stretch by factor 3, you're multiplying the y values of f of x by 3, right? F of x is the y value of this function. If you multiply that by 3, you get the vertical stretch. So when you do the horizontal shift, you get y equals 3f of x minus h, where h is the vertical shift. And your vertical shift is 4, so it's 3f of x minus 4, which equals 3 times 1 over x minus 4 squared. Okay? So you're replacing the x you have up here by x minus 4. Okay? And you remember it that way. You don't necessarily have to use this notation. We're going to be using it a lot, so it's a very good idea to use it. And if you use it, then if you happen to make a little error someplace, I'll be a little more forgiving. But I won't penalize you if you don't use it, as long as you see that the function at this point is 3 times 1 over x minus 4 quantity squared. I think this notation is the way to understand it. Okay, so when we shift by 4 units, we replace x by x minus 4. Okay? And that's exactly what the function notation tells me. People aren't necessarily totally comfortable with function notation. We haven't done that much with it. You're supposed to know it, but it's a little tricky. So if you don't, it's okay. Anyhow, your vertical shift of 6, your function is 3f of x minus h plus k. And again, this is something you'll benefit from knowing and understanding if you can now, because you're going to have to do it later anyway. It's kind of optional in this test. Okay? But you should understand that you take what you have here, which is your 3f of x minus h, but whatever. If you know that you replace x by x minus 4, you're going to get this anyway. You're going to then just add k to that. So it's 3 times 1 over x minus 4 squared plus 6. And that's the function that you have here. So there are two things you've got to know in this connection. First of all, how to draw it in a picture. Second, how to notate it. Right now, the picture is going to be more important than the notation. The notation counts too. Probably 6 points for the picture, 4 points for the notation. Okay?